Okay, let us start our discussion. Why I can say that sometimes the function is not differentiable at the cusp. This is the diagram for a cusp, horizontal cusp. The equation of the curve is y square is equal to x cube. If you draw like that, you can get like this. Why the function question comes? There is a tangent is x-axis. Okay, why the function is not differentiable at this point? We can say that we have to understand why it is like that. Means whenever here, what happens in this case, if you check the difference, whenever as a whole, keep in mind it is not a function. Y square is equal to x cube is not a function because at 2 x is equal to one value, you can get two different values. For example, x is equal to 1, you can get two values, you can get it. One is minus 1 and otherwise plus 1. You can get like this. See here, as a whole relationship y square is equal to x cube is not a function because x is greater than 0. You can get two values. One is plus x raised to 3 by 2 and minus x raised to 3 by 2. Then once if you get, we do not define dy by dx for a relationship that is not single value. So the function is not differentiable as a whole. But as two separate functions, if you consider upper branch y1 is equal to x raised to 3 by 2 and y2 is equal to x raised to 3 by 2 can get defined only for x is greater than 0. What happens in this case? The right hand derivative, if you check it, different dy by dx is equal to becomes 3 by 2 as x. As x tends to 0, they becomes dy by dx becomes 0. The left hand derivative. But what happens? Right hand derivative you can get 0. Right hand derivative exists, but they may be, but coming to the left hand derivative, there is no x is less than 0. Here, if I will show the diagram here, there is no x here. For x, we cannot get any curve y here. Therefore, at the 0 comma 0, there is no left hand derivative. That's region only. We can say that the curve is not differentiable at the point cusp. This is the region. The same thing they are telling here. There is no approach. There is no x is less than 0 to approaches. In calculation, differentiability needs both left hand and right hand limits to exist, and they are equal and they should be finite. Here, left is missing, so each branch is not two-sided differentiable at 0. Okay. Then question is, what happens? Both the branches are performed smoothly. If suppose if you take for x is greater than 0, what happens? If you take x number and if you check it, the differentiability is whenever x is greater than 0, and what happens in this case? Def Definitely, if you consider separate branches, then it is differentiable. Try to understand what I'm telling you. Here, if you take separate branches, left side and right side, if you take y1 is equal to plus x raised to 3 by 2 and check the differentiability for these branches, definitely we can exist. But as a whole, is not differentiable at any point because y square is equal to x cube is not a function itself. It is a relation. That's all we can say that if you consider a branch, separate branch, y is equal to x raised to 3 by 2 can the differentiability exist. I can say that for individual branches, this is we should understand. Okay. Then but in case of if you're coming to the some y square is equal to 4x, suppose parabola here like this. In this case also, even though it is not cusp, but vertical tangent exists here and left hand derivative is also not there here. In this case also, what happens in this case, as we move the point dy by dx tends to, I can say that they become uh, even though whenever if you check nearer to the origin, means I can say that if you want to check the derivative, what I want to say, the derivative at the origin, it is not possible. Even though the I can say that they will going to both the branches will going to give different things. But if you consider branch itself, what happens? If you consider individual branches, then also it is not differentiable, because dy by dx they will going to become tending to infinity at the I can say that they're telling the same thing here. Blue branches, okay, what happens again? Left side x is less than, there is no branches. One branch is light up, the other is also right, they are open at the right. Okay, if you check the differentiability, if you check it, what happens in this case? Y is equal to f of x and y is equal to 2 root x, 2 root x, and divided by x is equal to 1 root x. Means I can say that x tends to a 0, we can get infinity. Means here also, what I want to say here also the function is not differentiable at this point. If you consider individual branches, then okay, it is differentiable. Only thing is x should be greater. If you want to check the differentiability, whenever x is greater than 0, you can definitely separate branches, the differentiability occurs. But if you consider both the branches, you can get, it is not a function again, it is also a relationship. You cannot get a you can say that mm, differentiable. If you consider branches, individual branches, then yes, it is a differentiable. But even though if you consider a one branch, and if you check the only if you check only one branch and check the differentiability at 0, you can get the right hand derivative becomes almost equal to infinity. And then there is no question of left hand derivative, because there is no point exist here for the curve x is less than 0. Therefore the function is not differentiable. Sorry, this is the curve is not differentiable at this also in case of parabola. This is how we can understand the things. Again, if you curve take x square is equal to y cube. In this case, y is equal to x raised to 2 by 3. In this case, the curve looks like this. Okay. In this case also, the whatever the curve is not differentiable at 0 comma 0, because if you check what happens in this case, if you check the origin, left side limit, left hand limit is become dy by dx is negative infinity. As x tends to 0 from the left side, it become negative infinity, and whatever the right side is positive infinity, therefore they not become equal. And then even though if they are equal, they are not defined also, they negative infinity. And the same thing with the works at the right side, as x tends to 0 becomes, what happens if you work out the dy by dx, 2 raised to x is becomes positive infinity, and left side it becomes negative. The blue arrow in that on the right diagram shows the slope blowing up to the positive infinity. The purple arrow is going to become minus infinity. The normal derivative, for normal derivative, what we need? We need left hand and right hand limit are equal, and the common value is finite. The here the left hand limit and right hand limit, they are also not equal to the, they are not equal, and also they are not finite number. Therefore I can say that they are not equal, or neither they are finite. Therefore I can say that y is equal to f of x is not differentiable at 0. This is how we can understand why at the cusp the function is not differentiable.